Hello, welcome to the next session of a traveling wave tube amplifier, which is nothing but the amplification process of traveling wave tube amplifier. Okay, so in the previous video lecture I have explained regarding the structure, the working, in detail the working, how the electron bunching occurs in the traveling wave tube amplifier with respect to the slow wave structure that is being utilized in TWTA. So let me proceed with the same mathematically, the amplification process of traveling wave tube amplifier. So normally the slow wave structure of the helix that is being characterized by the Brillouin diagram, what already we have discussed in the last video lecture. Okay, so in that diagram, that means the in the slow wave structure of the helix is characterized by the diagram what we have given, that is Brillouin diagram. Okay, that already we had discussed in the previous class. So the phase shift per period, of the fundamental wave on the structure is given by you can write theta 1 is the phase shift per period, which is nothing but beta naught into L, where beta naught is nothing but omega by V naught. Okay, is the phase constant, of the average beam velocity, and capital L I can write it as capital L is the period or pitch. Okay, so since the DC transit time of the electron T naught, I will call it as DC transit time, I will call it as capital T suffix 0. Okay, DC transit time of an electron is given by T naught, which is nothing but L by V naught. Okay, so the phase constant, I will call this as I am continuing this the same thing with from the Brillouin diagram, the equation where we have stopped. I think there we have stopped the equation with the 17 I will call this as equation number 18 and equation number 19. Okay. Now, the phase constant of the phase constant of the nth space harmonic is beta n is nothing but omega by v naught, which is nothing but theta 1 plus 2 pi n divided by v naught into t naught. Okay, v naught into t naught. Okay, so that in general I can write it as theta 1 by v naught into t naught can be written as capital B naught, sorry, a b naught plus 2 pi n by L, because L I can write it as here, which implies L is nothing but v naught into t naught. So, v naught into t naught L, 2 pi n by L. So, theta 1 by L, I can write it as theta 1 by, so this I can change it as theta 1 by L, which becomes equal to b naught. Okay. So, theta 1 by L. So, this equation changes to theta 1 by v naught t naught plus 2 pi n by v naught t naught. So, v naught t naught is nothing but L, theta 1 by L plus 2 pi n by L. So, theta 1 by L is nothing but beta naught plus 2 pi n by L. That is nothing but this one. Okay. I think it is clear for you. Beta naught plus 2 pi n by L. Clear? So, I will call this equation as equation number 20. Beta naught plus 2 pi n by L is nothing but the equation number 20. So, in equation number 19, the axial space harmonic phase velocity is assumed to be synchronized with the beam velocity for possible interaction between the electron beam and the beam electric field. That is nothing but I can write it as VNP is nothing but V naught in general. Okay. So, I will write that one. In equation 19, in equation 9, it is not equation 19, it is in equation 20. In equation 20, the axial space harmonic phase velocity is assumed to be synchronized with the beam velocity, for possible interaction between the electron beam and electric field. Okay, that is V and P, I can write it as V naught. Okay. Okay. So, equation 20 is somewhat identical to that of equation 30. You can see that equation 30 is nothing but capital B naught plus 2 pi n by L. You just verify the previous thing. Okay, previous derivation with respect to the Bernoulli diagram. Okay, so we had derived this equation. That is, I think that equation is nothing but equation number 13. So this equation 20 is identical to equation 13. Okay, in practice, I can write the DC velocity of the electron the DC velocity of the electron is adjusted to be slightly greater than, keep in mind, the DC velocity of the electron is slightly adjusted, I will underline that word, slightly adjusted to be slightly greater than the axial velocity, the axial velocity of the electromagnetic wave, axial velocity of the electromagnetic wave for energy transfer, okay. So when a signal voltage is coupled into the helix, or we are giving a signal voltage to the helix, the axial electric field exerts a force. That already I explained to you. There will be a force. That force is nothing but Q into V cross P, okay, or F is minus E into E, capital E, where E is nothing but del into V, dou into V, so okay, or gradient into V, I can write that one, okay. So that I am writing here, that is when a signal voltage is coupled into the, when a signal voltage is coupled into the helix, the axial electric field, that will exert a force, okay, on the electron. The axial electric field will exert a force on the electron as a result of the following relationship, okay, as a result of the following relationship, that is nothing but F is nothing but minus E into E, or and E is nothing but minus del into, okay. So based upon this following result, there will be a force on the electron, okay. So when a signal voltage is coupled to the helix, the axial electric field that will exert a force on the electron with respect to the following relationship, okay. So the in case of what you call as a traveling wave tube, I have explained there that the electron that is being entering into the zero electric field are not affected, but the electrons entering the retarding field are decelerated, and those in the what you call as accelerating field are accelerated. So they will be formed a bunch centered, that is being about those electrons that enter the helix during the zero field, okay. So I will explain with that with a diagram here. Just take down this diagram. Okay. So I will take 3 point here. Okay. So let me just verify that one. So this is the electric field. There will be I'll just let's just write like this. This is these are electrons, okay. This and all those things are electrons. These are electrons. Okay, electron beam. Electron beam. So I will just so here I will write this is nothing but a retarding field this 2 is nothing but the retarding force okay. One minute. So this is nothing but accelerating field and this one is the accelerating force. Okay, retarding field, retarding force, accelerating field, accelerating force. So this can you can write this as a what you called as these are electron beams that already I written. So these are this you can write this as retarding electrons. If you want, you can write this as retarding electron. Okay, and if you want, you can write this as accelerating electron. Okay, so this is the figure or interaction of electron beam and electric figure. Interaction between which are entering into the zero electric field are not affected, okay, are not affected, okay, whereas the electron that is entering the retarding field, the electron entering the retarding field the electrons entering the retarding field are decelerated, okay, decelerated. What I told, the electron that are entering into the the electron entering the into the electron that are entering into an electric field which is retarding, these electrons are retarded. Okay, the electron that is entering the retarding field are decelerated. Okay, that I can, or in other method I can write the electron. I can write the electron that are entering into an electric field which is retarding these electrons are retarded. These electrons are retarded. In the sense what I am explaining, that is speed of such electrons get reduced. That is speed of such electrons get reduced. I think it is clear. Okay. Similarly, next word sentence is the electron entering into the accelerating field are accelerated, or I can write what the electron that is entering into the accelerating electric field gets accelerated. So what happens? So the bunching of electron takes place. That phenomenon is being shown in the figure. Okay. So what happens? Bunching of electron. So the bunching of electron takes place. This phenomenon is shown in the above figure. Okay, this phenomena is shown in the above figure. Okay, that means they will form forming a bunch centered about those electrons that enter the helix during the zero field. Okay, if you want, you can also write that one. Okay, they being forming a bunch centered about those electron that enter the helix during the zero field, that process is being shown here in the figure. Okay, so now what happens? The speed of the electron will be more than the wave velocity, so more number of that also I will write. So what happens? The more number of electrons enters into the retarding field, these electrons which are entering the retarding field will transfer the energy to the what you called as electric field. So electric field electric field get amplified. So now the uh, electric field gives energy to microwave signal voltage. So what happens? The voltage also get amplified as electron that propagate more. As electron is being propagated inside the slow wave structure, more interaction will be taking place between the electron and the electric field. So bunching becomes more compact at the end of the helix. That is been taking place in traveling wave 2. So I will write that one. That is, since the DC voltage, since the DC velocity, I will write as DC velocity of the electron is slightly greater than the axial velocity, more electrons in the retarding field there will be more electrons in the retarding field than in the accelerating field. Keep in mind, okay. If the DC velocity of the electron is slightly greater than the axial velocity, more electrons will be there in the retarding field than in accelerating field, okay. And a great amount of energy is transferred, and a great amount of energy is transferred from the beam to the electromagnetic field, clear. So if you want, you can write in bracket also, but now speed of electron is more than the wave velocity, what I can write, since the speed of the electron is more than the wave velocity, so more number of electrons enters into the retarding field. Okay. What happens? These electrons which are entering the retarding field, that will transfer the energy. These electrons that are entering into the retarding field will transfer the energy to the electromagnetic field. Okay. So what happens? What is amplified? So the electromagnetic field is amplified. So electromagnetic field is amplified. Clear? So now what happens? Now amplified electromagnetic signal, amplified electromagnetic field gives energy to microwave signal voltage. Now, amplified electromagnetic signal field gives energy to microwave signal voltage. So, what happens? So, this voltage gets amplified. As more and more number of electrons is being propagating, what happens? More interaction takes place. As more electrons beams propagate, more interaction takes place between the what you call as electron and electric field. Between the electron and electric field. So, what happens? So, bunching becomes more compact at the end of the helix. So, bunching becomes more compact at the end of the helix. Okay. So, this is the thing that is happening here. If you want, I will write in another method. If you want, you can take this also according to a textbook method, where I have stopped here, that is from this point electromagnetic field. What happens? Great amount of energy is transferred from the beam to the electromagnetic field. So, what happens? The microwave signal voltage is in turn amplified by the amplified field. This the bunch continue to become more compact, and a large amplification of the signal voltage across the end of the helix. That is the things what I have given here. Okay. So, the magnet, I am not writing again. So, the magnet what I have indicated here in that diagram of the structures of the traveling tube produce an axial magnetic field. That already I have written, but then also you take out to prevent, for what purpose? To prevent spreading of electron beam. The magnet produce an axial magnetic field to prevent spreading of the electron beam. Spreading of the electron beam as it travel down the tube. Similarly, I have kept an attenuator. It's not an attenuator placed near the, where I have placed nearer the center of the helix. What it will do? It will reduce all the wave. Reduces, that is, I told it will bound it. Okay. Reduces all the waves traveling along the helix. Center of the helix, reduces all the wave that is traveling along the helix to nearly zero. So that the reflected wave from the mismatched load can be prevented from reaching the input and causing oscillation. Okay, clear? So that is the main purpose for what you call as the detonator. Okay, so the bunch electron that is emerging from the detonator, the bunch electron that is emerging from the detonator that will induce a new electric field, with the same frequency, that will induce an electric field with the same frequency. So what happens, this field will in turn induce a new amplified microwave signal on the helix. Okay, this field in turn that will induces a new amplified microwave signal, induces new amplified microwave signal on the helix. Okay, so this is something regarding the amplification stage, what is happening in the theoretically what is happening in the traveling wave tube. Now we have to go for the mathematical analysis with respect to this one. Okay, so let me stop here. I will take the mathematical analysis because it has got some more portion to complete it. So I will discuss in another video as a part 2 of this amplification process. Okay, thank you.